Okay, this video is designed to help you a little bit with equations of circles. But before we get on to that, just a little bit of a recap. You should have already come across linear equations, and they're generally of this form. That's the y-intercept form, and when they're in this form, you know that's the slope, and here's your y-intercept. You might also see them written in general form, which is ax plus by equals c, and we like a to be an integer and greater than 0. We also know the general form of a quadratic, but again a quadratic can be expressed in the form ax minus h squared plus k, and when it's in this form we are able to then say, well, that gives us the vertex hk. So just like a linear and a quadratic, a circle has a basic equation, or a general form of an equation if you will, and that is of the form x minus a squared plus y take b squared equals the radius squared. Now of course you can, depending on whichever book you look at, they might use h and k or whatever different variables here, but it's the same thing. And when we have that, that means we have center a, b, and as I said before this, we've got the radius is r. So we can now go forwards and backwards with this. If we have, let's say we are given an equation where it's x take 4 squared plus, let's say, y plus 3 squared equals 9, we can say straight away, well, that means the center is 4, so reverse the sign, and then negative 3 here. The center is 4 minus 3, and the radius, right, so this is r squared, which means r must be 3. Okay. Similarly, just do one more. What if I had just x squared plus y take 7 squared equals 11? This would mean it's got center. There's nothing here. That's like x plus 0. So we've got center is 0, 7, and square root of root 11. Not sure what that is, and we write just root 11. I guess if we want to, we can pop units there if we're being really good about it. We can now go back the other way as well, because what if I said, all right, can you tell me the equation of the circle if it has center, pick a number, any number, let's go minus 2 and 8, and it has a radius of 2 root 3. Well, I can plug that back into this equation, and that means it would be x plus 2 all squared plus y minus 8 all squared equals 2 root 3 all squared, which would be 4 times 3, 12. Okay, so pretty simple. And how I give you this information can change a little bit. So I can be a little bit sneaky. So I could now say, find the equation of the circle that has center 2, 4 and passes through the point negative 1, 6. How do we do that? If you want to picture this, you've got a circle. Let's see how good my diagram is now. So we've got a circle here. Not great. So 2, and up here is 4. So that's the point 2, 4. And we've got a coordinate minus 1, 6 up here. So we've got this circle that's passing through. And I've cut off my bit of paper there. So we've got this circle that's going, oh, that's a really bad drawing of a circle, sorry about that. Normally better than that. And it's passing through the point minus 1, 6. So here we've got the point minus 1, 6. Now some of the way that you could do this would be you could work out the distance here to get the radius, but a quick way is our good old method and our friend called substitution. So from our center we know that we've got x minus 2 squared plus y take 4 squared. Now this equals your radius squared. This is my x value. This is my y value. So if I just sub it in here, I will end up getting the radius. So that can now be minus 1 take 3 squared plus 6 take 4 squared. That will give me my radius squared. So 16, 6 take 4 is 2, plus 4 equals my r squared, so 20. So I can say, therefore, the equation is x minus 2 squared plus y take 4 squared equals r squared. Right? So we can do a whole lot of different things like that as to how I can give you this information. Instead of saying, here's the center, here's the radius, I can disguise it a little bit, and you just have to try and figure out the information that you've got. Drawing a diagram always helps. So that's sort of part one of the circle. The next bit is if you are given the equation of the circle in expanded form. So consider something like this: x squared plus 6x plus y squared minus, let's go 2y equals 7. And what I want from you is, can you tell me the center and the radius of that? Which means you have to put it in the form x something squared plus y something squared equals your radius squared. Now, in order to do that, we have to cast our minds back to completing the square. And I think completing the square is really simple if you remember how to expand perfect squares, and you know that. So let's just take a moment over here to go back and have a look at perfect squares. So I hope you remember that when we've got something like this, x plus 5 squared, this is x plus 5 times x plus 5, and it expands to be x squared plus 10x plus 25. If I had, let's go, x minus 4 squared, that would be x squared take 8x plus 16. And we can go on like this all day. We know the pattern is that this is double here, and this term is that one squared. So if I wanted to go backwards, if I had x squared plus 12x, if I look at this, that's telling me that it has to be plus 6 over here. And when I expand that, then I get a plus 36. I hope that makes sense. Just do one more. What if I had x squared take 18x? Again, we go half of 18 is 9, and because that's a minus, it's x take 9 squared, and so over here that means 9 squared, we get 81. Okay, so when we come over here to our question, what I'd like you to do is focus on these two for now, and we go, okay, I've got an x squared and I've got the 6, so half of 6 is 3. That means in my bracket I'm going to have x plus 3 squared. But when I expand, so when I expand x plus 3 all squared, I get the x squared and I get the 6x, which is what I wanted here, but I get a plus 9. So what I've done from going from here to here, I've actually added 9 to this side. That's okay. All I have to do is, to keep it all balanced, is I have to add 9 to the other side. Sweet. And now we focus on the y's. So we look at, this will come up, we look at the y bit now, and we go half of minus 2, so that's minus 1, and that becomes y take 1 all squared. And again, when I expand y minus 1 squared, I get y squared take 2y plus 1. So what I've actually done, I wanted the y squared and the minus 2y, that's here, but I've added in a 1. Again, what I do to one side, I have to do the other, so I just add 1 here. So now what I have is I've got x plus 3, I've got y take 1, 7 plus 9, 16 plus 1 is 17, and I can now say, therefore, my center is negative 3, 1, and it's got a radius of root 17 units. Huzzah! Shall we do one more just to make sure that we've nailed it? Now obviously you don't have to write this down all the time. That was just reminding you about how we use perfect squares, because sometimes we can forget our expanding when it's been a while. Let's switch colour because I like that yellow. Okay, we'll come up with another one. We'll go x squared. How about take, pick a number, any number. We'll go 10x plus y squared. Notice they're sort of even here. That makes it simple. Obviously, if you have an odd number, you halve it, you get a fraction, but you've got calculators with fractions, so you can do it. But we'll keep it simple for today, and we can say plus 8y equals any number, any number. How about we go 10? Okay, so again, we start with this. I look at the x, take 10x, x squared, take 10x, and straight away that means that has to be x minus 5 all squared in the bracket, because I've just halved that 10. But when I expand x take 5 squared, I get the x squared, I get the minus 10x, but I also get a 25. So on the other side, I've got the 10 here, I have to add the 25. Now I look at the y, that's going to be y, half of 8 is 4, so plus 4 squared. When I expand this, I get y squared plus 8y plus a 16. So I've added 16 to the left hand side. Let's add 16 to the right hand side. Tidy this up. I've got x take 5 squared plus y add 4 squared. What have we got? 10, so 30, 40, 51. And therefore I've got a center of 5, negative 4, and a radius of root 51 units. And just to remind you about this, if you got your surd here, if it was, let's say, root 20, just remember that you have to simplify that. Your graphic calculators would do it automatically. That looks like a 26, root 20. But I'd like to think you can do it without using a calculator. You look for a square number that goes into 20. So in this case, it's going to be root 4 times root 5. And we know that the square root of 4 is 2, so that's 2 root 5. One more for good luck. How about we go 32? If I had root 32, what's the biggest square number that you can think of that goes into that? Remember, your square numbers are 4, 9, 16, 25, 36, etc. They're getting quite big now. So 16, so that would be root 16 times root 2, 16 2s are 32, and that means that becomes 4 root 2. So if you can simplify it, please do so. Clearly in this case, 51, prime number, none of those go into it. So that's how we would leave it. So I hope that was a good refresher for you on how to complete the square in order to get the center and radius of the circle. You can read on in your textbook. There is also a formula that you can use to do that, but that's pretty straightforward, and I think you can follow that yourself. Good luck!